In this video, we're going to look at some factoring examples. The first two examples are just what we call common factoring. First one, we can take out 4xy from each term, leaving us with 2x squared minus 3y squared. Now the second one is a little bit more difficult, and sometimes it helps if you compare it with a question like 8y squared minus 20y. Here you could take out a 4y from each, leaving you 2y minus 5. Think of that y as that bracket 2x plus 1. So here I can take out a 4 from both the 8 and the 20, and I can take out one copy of 2x plus 1 from each of the terms. From there I'm left with a 2 times 2x plus 1 from the first term, and a minus 5 from the second term. I can simplify what's inside that square bracket. These examples involve what we call a difference of squares. The first example is a real simple x plus 3, x minus 3. X times x is x squared, and 3 times negative 3 is negative 9. Now if you were to FOIL this to check, you would get a 3x minus 3x as your middle two terms, which simplify to just 0x. Now the second one is also a difference of squares, but there's a little bit more going on. We first get 4x squared plus 9y squared z squared. The second one is 4x squared minus 9y squared z squared. But we're not done here yet. We can actually factor the second bracket with the minus again. And this is why you see the words factor completely, to remind you that you may have to do multiple steps sometimes. These examples involve what we call trinomial factoring. In the first example, we get x minus 8 and x plus 5. Again, you can FOIL to double check this. But the way I look at it is, first, I know x squared has to be the x and the x, so I write those in the beginning of each bracket. And then I look at what would give me 40. And in this case, 40 could be a multiple of things. 1 times 40, 2 times 20, 4 times 10, and 5 times 8. And you have to figure out what combination of those will give you that 3 in the middle. And in this case, it was the 5 and the 8. So that's why I chose the 8 and the 5. And then it was a negative 40, so I knew one was one symbol and one was the other. One was negative, one was positive. I chose negative 8 and positive 5 because I wanted a negative 3 in the middle. Negative 8x plus 5x gives me that negative 3x in the middle. So I'm basically looking at it in terms of reverse FOIL. Now the second example is a little bit more complicated because we have a leading coefficient other than 1. So I look at it in terms of that 2x squared. The only thing giving me 2x squared is 2x and x. I know with that y squared on the end that each is going to end with a y. 21 is most likely going to be 3 and 7. It could be 1 times 21, but most often it'll be that 3 times 7. So I have to figure out what order to put the 3 and the 7 in. So if I put a 7 here and a 3 here, and if we take a second to look at things, this would be 7xy, and this would be 6xy. What combination of those will give me a positive xy in the middle? Well, it'll be 7xy minus 6xy. So I want a positive 7 and a minus 3 in order for this to work. Now this has always been the method I use, which is I refer to it as reverse FOIL, if you will. There are some other methods out there, and do what works for you if you have a different method. Here's a couple of more examples. Now this first trinomial, you'll notice that everything is a multiple of 4y. So we can take out a factor of 4y, leaving us with y squared minus 5y minus 24. So by factoring out that 4y, we get a much nicer looking trinomial. 4y. Again, we know it's going to be y and y. 24 could be a multiple of things, but 8 and 3 will give me that 5 in the middle. I will need a negative 8 and a positive 3. Again, double check, you get negative 8y and positive 3y, which add together to give the negative 5y. The second example is a little bit more complicated. We can't factor out anything, so we're going to have to work it as is. Now, if you want, you could multiply out all the different things. 8 could be 1 and 8, or 2 and 4. 45 could be 1 and 45, 3 and 15, or 5 and 9. And you have to determine which combination of these will give us that 18x in the middle. I'm going to start with 4x and 2x. Again, it's usually the 4 and the 2, not the 1 and the 8. Not always, but usually. Now, when I look at the 45, I would try the 5 and the 9 first. But I know that that's actually not going to work if you actually try it. It actually ends up being the 3 and the 15. And in this order. Again, if we look at this, this gives us 30x, and this gives us 12x. So if we have 30x minus 12x, we get that 18x in the middle that we wanted. So we want a positive 15 and a minus 3. This last example is an algebraic fraction that we wish to simplify. Now you'll notice both the top and the bottom do have some factoring involved, so let's start with the factoring. The top one, I can take out 5x from every term, leaving me with x squared plus 2x minus 8. The bottom, I can take out an x squared from both terms, leaving me x squared minus 16. Now, the top it factors to 5x, x plus 4, x minus 2. And the bottom is a difference of squares, so you get that x squared, then x plus 4, x minus 4. You'll notice we can factor out or divide out a few things here. We can divide out the x plus 4s, and we can divide out one copy of x, leaving us with just a 5, x minus 2 on top, 1x, and x minus 4 in the denominator.